are what? Pure imaginary. So meaning that when you take ZC minus ZA divided by ZB minus ZA, we get a real number. That is meaning that they are collinear. But when you get a pure imaginary part, it means that those points are perpendicular. You remember when we are studying 3 points are collinear or 3 points are perpendicular. Then if even here in a complex number, when they are collinear when ZC minus ZA divided by ZB minus ZA are equal to a member of real number. So when we take ZC minus ZA divided by ZB minus ZA, we get imaginary part. So it means that they are perpendicular. So let us try to see examples so that you can understand it very well. Okay, examples. We have example number 1. Example number 1 is saying, let A, B, and C be the points with affixes ZA. Our ZA is negative 1 minus I. Our ZB is 2 plus 2I. And ZC is 3 plus 3I, respectively. We have 3 complex numbers, ZA, ZB, and ZC. So we are going to show that if those complex numbers are collinear. Remember the formula of a collinear. We have seen that they are collinear if ZC minus ZA divided by ZB minus ZA are a member of real number. So if they are a member of real number, it means that they are collinear. So we're going to show that they are collinear. So we have number 2 also. Number 2 is saying, let A, B, and C be the points with affixes ZA, which is 2 plus I, ZB, which is 3 plus 2I, and ZC, which is 1 plus 2I, respectively. Show that AB and AC are perpendicular. So we have seen that they are perpendicular if ZC minus ZA over ZB minus ZA are pure imaginary part. Is what? Pure imaginary. Is pure imaginary. So let us try to answer number 1. Our number 1 ZA is negative 1 minus I. ZB is 2 plus 2I. ZC is 3 plus 3I. Then A, B, and C are collinear points if and only if ZC minus ZA divided by ZB minus ZA is a member of what? Real number. Okay, let us try to see if that division is a member of real number. So what is ZC? 3 plus 3I minus, I have to put here bracket because you know that negative changes each and everything. ZA is negative 1 minus I divided by ZB, which is 2 plus 2I, minus ZA, which is negative 1 minus I. So now the answer is 3 plus 3I minus minus becomes positive, that is 1. Then minus minus I, that is positive I. Divide by 2 plus 2I. Then minus minus 1, that is positive 1. Then minus minus, that is positive I. So now the answer is 3 plus 1. 3 plus 1, that is 4. 3i plus I, that's 4i, divided by 2 plus 1, that is 3. 2i plus I, that's 3i. I hope you remember why I'm adding 2 with 1 and 2i with I, because we add the real part together, even imaginary part together. We first add the real part, and finally we add the imaginary part. So now, we are not allowed to leave the answer in this form, because this is not algebraic form. So now, we have to express this in algebraic form. Remember, what do we do to express this one in algebraic form? We multiply up and down the conjugate of denominator. So that is 4 plus 4i times 3 minus 3i. Because the conjugate of this denominator, it is negative because you have a positive here. Then divided by 3 plus 3i times 3 minus 3i. So now the answer is 4 times 3, that is 12. 4 times negative 3, that is negative 12i. Then 4i times 3, that is 12i. Then 4i times negative 3i. 4 times 4, that is negative 12. I times I, that is I squared, negative 12 I squared. Divided by 3 times 3, that is 9. 3 times negative 3, that is negative 9i. 3i times 3, that is 9i. 3i times negative 3, that is negative 9i squared. So finally, the answer is 12, negative 12i plus 12i, that is 0. I squared, that is negative 1. Negative 1 times negative, that becomes positive 12. Divided by 9, negative, that is 9 here. Negative 9i plus 9i, that is 0. I squared is negative. Negative times negative becomes positive. Then answer becomes 12 plus 12, that is 24, divided by 18. By 3, that is 8. By 3, that is 6. By 2, that is 4. By 2, that is 3, which is a member of real number. Which is a member of real number. Therefore, A, B, and C are what? Are collinear. So that is the answer. Since we get a real number, which is 4 over 3, it means that A, B, and C are collinear. I think that you don't have any question here. Do you have any question? Yeah, thank you, it is clear. Let us do number 2. I hope there is no problem with number 1. Let us start number 2. Number 2, we have ABC, where ZA is. Our ZA equal to 2 plus I. Our ZB equal to 3 plus 2i. And ZC equal to 1 plus I. Yeah, 1 plus 2i. Yeah, thank you. 1 plus 2i. So we're going to show that AB and AC are perpendicular. So AB, vector AB, and vector A AC are perpendicular if and only if ZC minus ZB, minus ZA divided by ZB minus ZA is pure imaginary. Is pure imaginary. So we're going to show that this is pure imaginary. If you find that it's not pure imaginary, they will not be what? They will not be perpendicular. Okay, what is ZC? ZC is 1 plus 2i. Minus, we have to put here bracket because negative changes each and everything. What is ZA? 2 plus i divided by ZB. Our ZB is 3 plus 2i minus, what is ZA? 2 plus i. The answer now is 1 plus 2i, then minus 2 minus i divided by 3 plus 2i minus 2 minus i. So here it equal to 1 minus 2. So we first deal with real part. 1 minus 2, that is negative 1. 2i minus I, that is I. Divided by 3 minus 2, that is 1. 2i minus I, that is I. So now here, we're not allowed to leave a complex number in this form. We have to change this one in algebraic form, yeah. So this is negative 1 plus I into bracket 1. What do? We change the denominator, we convert it into conjugate. So what is the conjugate of 1 plus I? 1 minus I. So divide by 1 plus I into bracket 1 minus I. So what will be the answer? Our answer is, let us proceed here. Our answer is, we have negative 1 plus I into bracket 1 minus I divided by 1 plus I into bracket 1 minus I. So negative 1 times negative 1, that is negative 1. Negative 1 times negative I, that is positive I. I times 1, that is I. I times negative I, that is negative I squared. Divided by 1 times 1, that is 1. 1 times negative I, that is negative I. I times I, that is I. Then I times negative I, that is negative I squared. So what is the answer here? We have negative 1. I times I plus I, that is 2I. Negative I squared. I squared, it is negative. Negative is negative, that is positive 1. Divided by 1. Negative I plus I, that is 0. Then I squared is negative 1 with this negative positive 1. So now the answer here is negative 1 plus 1, that is 0. We remain with 2I. Divided by 2. Answer is I. And as you can see here, this is pure imaginary. So we say that since ZC minus ZA divided by ZB minus ZA is pure imaginary. So that is to say, AB and AC are perpendicular. So that's the answer. Do you have any question here? Yeah, there is no question. So thank you for today. Let us meet next time. May God bless you.